right, we're actually going to start Unit 4, which is on the square root function. And I did split this into an A and a B part. So if you guys are organizing your 3-ring binders, you need to be opening it up to the very next unit and find that chapter Unit 4A title page. So everything from this point on goes into Unit 4, and let's leave Unit 3 behind. I do have your tests. I'll have them for you possibly by the end of class or tomorrow for sure. Now, if you want to make sure you come in for smart breakfast, all right, as we begin, we're actually going to have 2 parts today. One, we're just going to introduce, or we're just going to kind of dive into the shallow end of what I call rational exponents. What little bitty word is inside the word rational? Ratio. So I hope that when you see the word ratio, that it kind of brings to mind the idea of a fraction. We've never done any exponents that were fractions, but we're going to talk a little bit about them today. Okay? Grab your calculators. Let's just take a look at some easy things. Here's what we're going to connect today. Do you already know what the square root of 25 is? Anybody already know it's 5? Okay? If you do take the time to get your calculator, second square root is above the x squared key, and you type in 25, I believe you do get 5. Oops. All right, square root of 25 is, let's delete that extra minus. The square root of 25 is 5. Everybody good with that? Stop. Everybody. I want to talk about changing that to a fraction exponent. If you look at the number that's underneath, does it have a power? It doesn't have its own power. It's not 25 to the second, it's not 25 to the third, but it is considered to be 25 to the first. So actually that would be considered the power of the 25. Now, we are taking the second root, or what we call the square root, and that means that we are implied to have a little 2 in the corner. And what that is that's actually the root. So we're taking the second root, or the square root of 25. Now what you do, did you just notice at the top of your lesson, do y'all see at the top? Do y'all see something that looks like this? Where it's talking about power over what? Root. Y'all see that? Power over root. So if I go back and I jump and I look at what we've just looked at, that could be the same thing as 25 raised to the power of 1 over the root of 2, which could be expressed as 25 to the 1/2 power. Okay? Math may be getting crazy, but it is something that we can do. If you would, take your calculators, type in 25, find on the right-hand side your up arrow, which is your caret key, and you should have a box. Remember, I have an older version of the calculator. You have a better one. Do y'all have a box? Okay. And we're going to type in there 1 divided by 2, which is going to make it the 1/2 power. Now, do you still have 1 divided by 2 up high? Now, press enter. Okay, so for the first time, do you now see that square roots can now be expressed as fractional exponents? Okay. All right, let's talk about this. Let's talk about 5 raised to the 3rd power. What's 5 to the 3rd power? It's even up in the front of my room. 125. Now, press the math key. Do y'all see option number 4 says 3rd root out front? Do y'all see 3rd root on yours? I'm going to choose, I'm going to choose math, 3rd root, and I'm going to take this answer. What is the 3rd root of 125? That's basically saying what number multiplied by itself 3 times is 125? The answer is 5. Now, what if I chose to do this one as a fraction exponent? Well, I'm still going to do the power of the number. So what is the power of the number 125? What's the power of the number 125? Well, it doesn't have a power, so if it doesn't have a different power, then it's automatically a what? 1. Now, what is the outside root? Remember, it's power over root. So it would be, oops, in this case, it would be a what? It would be a 3. So type in 125, raise it up to, and guess what we're going to type in this time? What's the power or the fraction? 1 divided by 3. Okay. And I'm just trying to get you to make a connection between exponents that are fractions and these radicals, because technically that's actually a radical to the third root, or it's a radical to the second root. All right, like I said, we're just going to dive into the very shallow end of the pool. All we're going to do in the first 4 and then in the next 5 is rewrite things. Does everybody understand? Now, you can call it the exponent number over the index number, because technically this is called the index. That's the vocabulary word, but I always call it the root number. Okay? So I'm probably going to use power over root as my go-to expression when I talk about it. Power over root. Okay, let's talk about number 1. It says rewrite the expression radical form. Basically, if it's radical form, it's going to have this symbol in it. We call it square root, but remember, if you put another number in here, it could be third root. It could be what else? Fourth root. It could be fifth root. So I could put other numbers. Do not simplify. How would you change that to 10 to the 1/2? What does that mean? Well, top number is 1 is the what? Power. The bottom number 2 is the what? Root. So here's my symbol. 10 is under there. What numbers are implied to be involved with this? What's the power of this? 10 to the first power, and then that implied to be the what? Second root. Now, second root is the only power, the only root number you don't have to show. So that could be the same thing as square root of 10. You do not have to show to the first power, and you don't have to show the second root. They're implied to be there. It's kind of like if Miss Jessup goes around and they say, well, how old are you? And I say, well, I'm 48. I don't go around saying, I'm 48 to the first power. You probably don't go around saying, hey, I'm 16 to the first power. We don't do that, but it's implied to have an exponent of 1 if there's not one showing. Okay, number 2. This time I have 6 to the 1/3 power. Top number is my what? Power. The bottom number is my root. So I have the symbol. That's my radical. Put a 6 under there. That's 6 to the what? First power, and then I have the third root. Everybody good? I'm just wanting you to kind of get familiar with what the top number means and what the bottom number means. What about the next one? B. B is under there, and it has what? 3 is the power. That's under there. And then 2 is the root. If you did choose to leave the 2 out, it would still be correct. How about 4? Got a question for you. Does the 5/6 exponent, does it go with the 20? Or does it go with the x? Or does it go with 20 and x? You all are right. It only goes with the x. Typically, exponents go with the first thing that they're closest to. The closest thing to the x is the exponent 5/6. So I'm going to write my 20 out front like I normally write 20 because I don't have to do anything to the 20. But on the x, I'm going to use my radical symbol. Okay. When you use a radical symbol, what goes inside the radical? X. And then what are my 2 numbers that I need to put in the right places? 5 goes inside with x because that's x to the 5th power, and on the outside is what? 6. So that's 20, a regular 20, and I'm taking the 6th root of x to the what? 5th power. Power over root. Miss Jessup's going to repeat that a lot. Power over root. Now, you wrote it one way. Let's practice writing it in the opposite way. So how would I rewrite x to the 5th with a square root? How would I rewrite that? What are the 2 numbers? What's the implied number that's inside the index right here? That's implied to be a 2. Okay, is it x to the 2/5 or is it x to the 5/2? X to the 5/2. Power over root. Everybody good? Power over root. What about the next one? What number is implied to be with the 15? That's a 1. Is it 1/4 or 4 over 1? Power is 1. The root is 4. 1/4. 1 over 4. Anybody know what the next one's going to be? How many parts are involved with that? Is the 2 and the x together, or is it 2 separate from the x? 2 and the x are together because they do have parentheses around it. Everybody good? So I need to say 2 and x are together. So how do I show that 2 and x are really together? I need to have what? Parentheses. Now, is it going to be 5 over 3 or 3 over 5? 5 over 3. Power over root. Are you writing these down? Write these down. We're going to do some more of this tomorrow. You're not going to do a lot with it today, but we're going to do more of it tomorrow. I just want to introduce it today. Okay, how about example 8? 7 to the what? 1 over 6. That's implied to be a power of 1 outside number of 6. Okay, the last one actually has 3 parts. And technically the 5, the x, and the y are all underneath, but they're not all the same. Is everybody good? Over here, when I look at example 7, the 2 and the x were the same, and they were parentheses already. Here, they're not. So I'm going to have a 5, I'm going to have an x, and I'm going to have a y, all that are separate. Okay. What's the power on the 5? What's just the power? Just the 5. Just look at the 5. That's a 1. So it'd be 1/5 or 3 over 1. Or excuse me, 1/3 or 3 over 1. 1/3. Would be on the x. X would be what? 2/3. Because there's a 2 with the x. 2 is the inside power, still the outside root of 3. Anybody know what y would be? 6/3. What's the only thing about 6/3? You could change it to 2 over 1 or just 2. So you are correct. This is exactly the best way to express this. It's actually 5 to the 1/3. X to the 2/3, and y just to the positive 2. That is the best way to express the answer to example 9. Does everybody understand it? It's just inside number power over outside root. I just need you to get that phrase familiar today. Now, you're not going to have homework on that tonight. You're going to have homework on that tomorrow. So we're going to do a little bit with power over root today and a little bit more of it tomorrow. Have everybody any questions over 1 through 9? Everybody pretty good with that? We're just learning to rewrite a little bit. Okay, we're going to go to solving. Okay, solving is basically learning to undo something. Do you all remember when we, actually it's back in Unit 3 when we started it. I had something like x squared equals 16. Don't write this down. This is not on your paper. How did I solve to get just x? Like, I don't want my answer times itself twice. I want my answer just x. How do I get rid of it? Didn't I take the square root of both sides? What did we say happened whenever the square root and the square were together in the same time? They cancel each other out, and what used to be under there does what? Comes out. Guys, we're still doing that. And, of course, what's the square root of 16? 4. Don't forget what? Plus or minus. And that's what we did just a while back. Now, I want you to look at this, and I want you to go and look at this. We're going to do the same idea, but we're going to do it opposite order. Okay? Okay, let me go back again. Take a look at this. What did I start with? I started with what? I started with the square. And I did the square root. This time, I'm starting with what? A square root. So what does it say? Now remember, the square root is also called a radical. So it says get the radical by itself. Well, if I look, actually it is already by itself. So what does step 2 say? Square both sides. Okay, so square both sides means take this, put a big parentheses, and put a big 2 on it. Up high. Go to the other side. Put a big parenthesis, put a big 2 up high. That means multiply it times itself twice. Just like what happened when we did it before. What happens if the square and the square root are together? They cancel out. It doesn't matter which one you have first and which one you have second. If you have a square and a square root at the same time, they cancel. So what used to be under there, guess what? Comes out. So now I have x with no square root or no square on it. Now, it did cancel on the left, but it did not cancel on the right. So what's 6 times itself twice? 36. 6 times 6. Our squares are up there. Okay. Now, you are supposed to check to see, put it back in the original. So if I can imagine putting 36 back in here underneath the square root, is the square root of the number 36 equal to 6? Yes. So it does check. Okay. Number 2. What's my very first strategy say? Get the radical by itself. Well, my radical is right here. I need that by itself. How do I get rid of plus 3? I'm going to subtract 3. If you subtract it from one side, you have to what? Subtract from the other. Are you writing this down? So you have examples to look at in a few minutes. So now I have square root of m is equal to, what's 13 minus 3? 10. Now, I don't want m with that square root over it. I want m just m. How do I get rid of it? Parentheses and square it. Parentheses, big parentheses, and square that. That means you're timesing it by itself twice. What happens if the square and the square root are together at the same time? Cancel, cancel. Remember us doing that? So what comes out here is just what? M. That cancels on the left, but it does not cancel on the right. So what's 10 to the second power? 100. Everybody good? Everybody good? If we mentally put this back in, does it work? 3 plus the square root of what? 100. Does that equal 13? What is the square root of 100? 10. So 3 plus 10 would equal 13, wouldn't it? So let's just say, yep, it does check out if I try it. You are going to have to check your answers, because if you don't, you might get an extra one that's not going to work. Everybody understand what we're doing? The big idea is, how do you get rid of a square root? The big idea is, how do you get rid of a square root? How do we do that? You square it. How do you get rid of a square? If you square it, you square it. You double it, you square root it. Square root and square undo each other. Okay? All right. 2 down, a few more to go. Let's talk about 3. First things first, I need to get the radical by itself. Well, now the 2's under the radical, so the 2 and the y are both under the radical, so I can't get it out of there yet without getting rid of the square. How do I get rid of the square root? I got to square both sides. Big parentheses around the whole thing, squared. Big parentheses around this, squared. Everybody see what I did? Now, because the 2 is under there, the square root and the square cancel. Everything that's under there comes out exactly the way it is. So the 2 and the y both get to come out. What happens on the other side? What's 4 to the second power? 16. Now this time I'm not finished. I'm one step away. 2y equals 16. Divide out the 2. Okay, this is what we call solving square roots. Solving square roots. Now, I got to imagine doing what? I got to imagine putting it back into the original equation. So square root of 2 times something should equal 4. So if I put an 8 in there, what's 2 times 8? That's square root of 16. Is square root of 16 4? So that one actually does check. All right, let's move on to number 4. What's the very first thing I'm supposed to do? Get the square root part by itself. So that means just this part, right? Get the radical, or the square root part, by itself. That means I really should get rid of the 2 first. How do I get rid of the 2 that's in front? It's not added and it's not subtracted. I need to divide it out. So if I divide it out by 2 and 1, what do I have to do over here? Divide by 2. 2 divided by 2 cancels. I still have the square root over top of the x equals 4. How do I get rid of the square root? I just want my answer with x, and I don't want square root over it. Square both sides. Big parentheses, square the whole side. Big parentheses, square that whole side. X equals 16. Square root and square cancel, so what used to be under here comes out. 4 to the second power is 16. All right, let's keep going. Number 5. What's the very first step say? Get the radical part by itself. My radical part is where? And there's a 4m, but that's under the square root. So everything that's under there, I'm going to try to get that part by itself. So what needs to go? How do I get rid of minus 5? Plus 5 to both sides. Okay, now I have to still have a big square root with 4m plus 1 under it equal 0 plus 5 is 5. Now I really need to get this m out from under the square root. How do I get rid of the big square root? Square both sides. Square big parentheses around the whole thing. Square that side. Big parentheses over here. Square that side. What happens if you square a square root? They cancel out. Bing, bing. Everything that used to be under the square root comes out, which is really what I wanted. It does not cancel out on the other side, so you got to do 5 to the second power. 5 to the second power is 25. And I still got a little bit more work to do. Minus 1, and that gives me a 24. Divide by 4, m equals 6. Now, what are we supposed to do last to verify that our answer is truly correct? You're really supposed to substitute back into the original equation. So let's see if we can do this in our head. What's 4 times 6? 24. Plus 1. 25. That puts a 25 under the square root, doesn't it? What's the square root of 25? 5. Subtract 5, does it equal 0? Yes. So when we check it, it does work. Everybody understand what we're doing? 5 down, a few more to go. Number 6. Okay, is the radical part already by itself? Yes, I don't have to add or subtract anything this time ahead of time. So I'm ready to get rid of that big square root. How do I get rid of the big square root? Square the whole thing. If you square one side, you got to square both sides. You got to square one side, you got to square both sides. Now, the big square root and the square cancel. Everything that used to be under here comes out exactly the way it is. X was on top, 3 is on bottom, X is still on top, and 3 on the bottom. Except it's not equal to 2 anymore. Now it's going to be equal to 4. Everybody with me? Now, I have to solve and get X by itself, and you always use your opposite operation. So what am I going to do, Miss Caitlin? She says times it by 3. Because what that says to me is that's X divided by 3. And the opposite of divide by 3 is times by 3. So if you times one side by 3, the 3's cancel. 4 times 3 on the other side gives me 12. What am I supposed to do to make sure my answer's right? Put it back into the original. Imagine putting it back in up here. Okay, what's the square root of? So if I put the answer in, what's 12 divided by 3 underneath? 4. Is the square root of 4 equal to 2? Yes, so it does check. So you can mentally check, you can get your calculator and check, but you need to kind of check to make sure your answer is right. I need to do something in number 7 before I square both sides. What do I need to do first? Add 4s. So you want to get this square root part by itself first. So this thing I have to add 4. Everybody good? Equals 6. Now what do I do? Square both sides. I want to pull the 3x over 5 out, so I have to square everything here and square everything there. Square both sides. That's my go-to strategy, squaring both sides. Now what? Square root and the square cancel. Everything that's under there comes out. 3x over 5 is equal to, what's 6 to the second power? 36. This is going to be a big number. Somebody's going to have their calculator for us. Now, I actually have a 3 in the front and a 5 on the bottom. What that really means is I'm actually multiplying times 3 and dividing by 5. I usually like to get rid of those divide parts first. I like to get rid of the denominator. So let's times both sides by 5. Okay? So if you times one side by 5, you have to times the other side by 5. What is 36 180? Okay? What's left over here? The 3 and the x are still together. One step away, what do? Divide both sides by 3. My x answer equals 60. It's 3 times 60. I imagine putting it back. Okay. 3 times 60 over 5. What's 3 times 60? Is that 180? What's 180 divided by 5? 180 divided by 5. Is that 36? So that says the square root of 36 minus 4 equals 2. What's the square root of 36? 6. 6 minus 4, does that equal 2? Yes. So even if you imagine putting it back, it does work out. We've been on a good roll of having things work out. Okay, number 8. Ooh, it's different. It's different. I got to square both sides. If I try to get the radical by itself, well, if I look closely, the radical on the left is by itself, and the radical on the right is what? Also by itself. So what do? Well, if I square this radical, I'm going to get rid of the square root. And if I square that radical over there, I'm going to get rid of that square root. So basically, if I square both sides, the parts that are underneath have to be equal. Now, do you remember how to do it when you have an x on one side and x is on the other? Numbers on one side and numbers on the other. What do you have to do? I got to bring everything is alike to one side. So, is it okay if I bring 3x over here? How do I get 3x over there? You subtract 3x from both sides. So if I bring the x's over here, I need to take this number where? Over there. So how would I get rid of minus 13? Add 13. And now 13's not here. So what's left? It's 5 plus 13. 18. 5x's minus 3x's. 2x's. Divide both sides by 2. X is equal to 9. Guys, I did check it earlier. Do you accept my word that 9 does work? It does work. All right, let's talk for just a second about an alternate way to do it. Do you remember when we did intersection and we learned how to say, let's put everything in here, maybe in y1, and everything that was over here, maybe where? y2, and then try what? Intersection. That actually works. Let me just show you. It's not what we normally is our go-to, but if it's a crazy looking hard function and you're thinking, God, that looks difficult, the calculator way is another way to do it. Okay, do I have 3x plus 5? Now keep in mind, I had to type it in parentheses because I don't have the big long bar. I have an old calculator. Everybody good? So if I go zoom 6 and I watch it, here's the first equation and here's the second equation. Do they intersect? Remember how we trace? And I'm going to go over here closer to the intersection point. Oops. Trace. Go closer. Come on, Penny. Move, move, move. Just a little bit. That's pretty close. As long as I get a little closer to it. Now what do? Second trace, which is calc. Number 5. And then what? Enter, enter, enter. And if it did it right, I'm looking for the x answer should be 9. So do you see how there could be an alternate way to use your technology to solve for these? I just wanted you to notice that because that looks kind of tough at first. It actually didn't solve too bad, but there is another way to do it. What about 9? I would. But you notice the plus 3 is not just plus 3, it's plus 3 times this. So what if I do? If I do plus 3, it has to be plus 3 times the square root. So plus 3 times what? Square root. Basically what I'm doing is I'm going to move one of the square roots to the other side. So what's left over here? 2x plus 32 equal to 3 times the square root of x plus 2. Are my square root radicals by themselves? I'm ready to do my strategy of what? Square both sides. You got to be careful. When you put big parentheses square, that's everything on that side. Here, though, did anybody notice that I have an outside part and a square root part? I got to square the 2, and I got to square the square root. Every separate thing has to be squared. Does everybody see what I did? Square everything on the left, square everything on the right, even that outside number. What do you get over here? That's it, 2x plus 32 because the square roots cancel. Everybody okay with that? Everybody okay with that? What about right here in front? 9. Everybody good with that? What happens right here? The square root and the square cancel, so this part comes out, x plus 2. Now, what do I do with the, does the 9 multiplied times x, or is the 9 multiplied by everything? Since that was kind of grouped inside that square root, we now need to keep it what? You got to keep parentheses. That is the trickiest part to remember. That was kind of separated, but it's still grouped. No more square root on it, but it's still grouped. So now, what's 9 times x and 9 times 2? 9x plus 18. That's 2x plus 32. I got to move some things. Can you guys do it and tell me what you get? Anybody got an answer yet? I heard it. 2. I heard 2. Anybody else getting 2? Okay, 2 is right. I'm going to move my 2x over here. If I do, it becomes what? Negative 2x. Okay, and I'm going to move 18 where? Over there, and it becomes what? Subtract 18. What's 9x's minus 2x's? 7x's. What's 32 minus 18? 14. What do I have to do to finish this? Divide by 7. X would equal what? Could we have solved that a different way? Could we have went to the calculator and found it? Guess what the answer would have been? If I had done intersection on this, I probably would have done it right here on this step. I probably would have said, let this part be my y1, and let what? This part be my y2. And you could have let your calculator do it. Because, guys, it will give you the answer whether it's a nice, pretty decimal, or, whether it's a nice, pretty number or an ugly-looking decimal. Your calculator can do these kind of messy-looking ones. How many more we got? 1. Okay. Does anybody figure something's different about this one? Oh, I have a Y. That's right. I have a different letter, but it's still the same thing. It's just it's the same as solving for x. It does say equals 0. What's the first thing I'm supposed to do? Try to get the square root or the radical part by itself. So what needs to go? The plus 3 needs to go. So what happens? It's going to be minus 3. What do I usually do next to solve it? Square both sides. Square everything on both sides. If you square both sides, what happens? You get 2y minus 1 equal to, what's negative 3 squared? That's like negative 3 times negative 3. Negative 9 or positive 9? Actually, it's positive because it'd be negative times negative. How would this solve? Plus 1. So I get 2y is equal to 10. What's my answer for y? 5. Boy, that seems like it's just as easy as anything, right? Here's the problem. What are we supposed to do? What are we supposed to do? Put it back in. Okay. Square root of 2 times y minus 1 plus 3 should equal 0. So what's 2 times 5? Minus 1. So I end up with square root of 9 plus 3, and it should equal what? The square root of 9. 3 plus 3, does that equal 0? That actually equals 6 equals 0, and that's, guess what? That's going to be false every day of the week. This answer does not work. All right, here's a phrase that I got to make sure you know. This word is called extraneous. Can you say that for me? Extraneous. What itty-bitty word is in the word extraneous? Extra. Guys, this one has an extra. In this case, the only answer looks nice. Oh, it solves so good. But it don't work. There's a clue. Before I ever got close to solving for 5, there is a clue that that might have happened. Something up here was not expected. Miss Caitlin, -3. Right here. Let me ask you a question. If you take the square root of any number, is your calculator going to give you a negative answer? No. Well, guess what the answer to this one is? No solution. The 5 looked good, but when I checked it, it did not work. Does everybody hear me? Okay. Right here, jot this down. Put you a big star. Write that down. Cannot take a square root and equal a negative. Does everybody understand? This says right here, this line right here says, I am trying to take the square root of some answer, and it's supposed to equal a -3. That was my first clue. So if I had caught it right then and there, I probably would have said, stop, that can't happen, no solution. Guess what would happen if we had taken time to put this in our calculator into Y1 and this in our calculator into Y2? Guess what would happen? They would not intersect. They would not intersect. If I went in there and said, let me clear and clear. If I'd went in there and tried to solve it, I'd have to use an x, square root 2x minus 1. And then the other side is -3. Does everybody see what I did? I typed the left and I typed the right. If I graphed it, there's my first one. Do these two ever intersect? Does everybody, can you visually verify that they have no solution because they do not intersect? So there are a few. All right, on the homework on the back, I think there's 1, maybe 2. I can't remember for sure, but I know there's at least 1 that has no solution.